Hello friends, welcome to my channel An Engineer's Guide. In this session, we'll learn how to calculate the MAWP of pressure vessel. This is the part 1 of the MAWP calculation series, where we will cover the MAWP calculations for different pressure vessel components one by one. But before moving forward, please subscribe to my YouTube channel. It's free for you, but it will give me a lot of motivation to create such a useful videos for you. Also, don't forget to click on the bell icon to get the latest update from our channel. Thank you. So let's understand what is MAWP. As per clause UG 98, section 8, division 1, it is defined as the maximum allowable working pressure for vessel. The maximum allowable working pressure is measured at the top of the vessel in its normal operating position at the designated coincident temperature specified for that pressure. Now you might be wondering that why is the pressure measured at the top and not at the bottom? Let's find the answer to this question. Now keep in mind that the MAWP is calculated for every essential part of the pressure vessel, and among these components, the one with lowest MAWP is considered as the MAWP for the entire vessel, adjusted for any static head that may exist between the part considered and top of the vessel. So till now you just understand that we need to adjust the static head between top of the vessel and part considered. Now let's simplify the concept through an example, which often makes understanding easier. First, take a note of the design data required for MAWP calculations. So here we are considering the design pressure as 2.5 MPa, design temperature as 350 degrees Celsius, material of construction as SA516 grade 70, corrosion allowance of 3 mm, joint efficiency of 1, and allowable stress is 128 MPa, which is nothing but the allowable stress of SA516 grade 70 at 350 degrees Celsius. Now let's take the note of the dimensional specification essential for MAWP calculations. Here we are considering inside diameter as 1000 mm, shell length as 1500 mm, dish type as a 2:1 ellipsoidal, straight face is 50 mm, dish inside height, which is d by 4, is equal to 250 mm. Now first of all, let's calculate the static head of top head. So here P is equal to rho GH, which is the well-known formula for to calculate the static head. So rho is the 1000, G is the 9.8066, and H is the 0.250 plus 0.080. So 0.050 is nothing but the straight range. So here you got the answer as 2941.980. Generally, we recognize that the pressure is measured in units such as kg per cm square, Newton per meter square, or pascals. However, based on this particular equation, it appears the pressure inside a vessel might be expressed in a slightly different units. Let's investigate further. We know the units involved here. Here, density is a kg per meter cube, gravitational acceleration is nothing but meter per second square, and height is in meter. Now multiply this together, which is the unit of pressure as kg per meter second square. At a first glance, these units seem unfamiliar or confusing. So pause the video here for some time and try to convert this expression into more recognizable unit. If you got the answer, then please post your answer in the comments. Now let's break down it together. First of all, recall that the force is defined as mass into acceleration. So the unit of force is in Newton, and that of mass is kg, and that of acceleration is meter per second square. If we divide both sides by meter square, we get Newton per meter square on left side and kg meter per second square per meter square on the right side. Now further modification, we get the unit as kg per meter second square on the right side. So which is exactly matches the unit we previously derived. So we can conclude that kg per meter second square is equal to the Newton per meter square, which confirms it is a valid and well-known unit of the pressure. These units remind me of a story. Let me share with you. I think you will enjoy it. So I hope guys you will really enjoy that story, and please put in the comments if you like the story. So let's start the story. One day Newton and Einstein met at a function. During the event, Einstein began boasting, "I am the greatest mathematician. Give me any puzzle and I will solve it in seconds." Newton simply smiled and accepted the Einstein challenge. Newton said, I will hide somewhere in this room. You must find me. If you can, I will accept that you are the greatest mathematician of all the time. Then Newton found a box measuring 1 meter by 1 meter, stood on it, and said, Hello, Einstein. Now try to find me. Einstein smiled and replied, Newton, how silly are you? You are right in front of me and still asking me to find you. Newton smiled again and asked, Are you sure I am in front of you? Einstein responded, Of course, there is no doubt. You are right there. Smiling once more, Newton began his playful challenge. Can you see the surface I am standing on? He asked. Yes, Einstein said. This is the square with a dimension of 1 meter by 1 meter, Newton explained. Its area is 1 square meter. And remember, Newton per meter square isn't a Newton, it's a Pascal. Einstein looked embarrassed and admitted, Yes, Newton, you are right. This story is purely fictional and does not depict any real events. It's simply a creative way to remind us of common unit of pressure, which is Newton per meter square, is nothing but the Pascal. So guys, this is all about today's session. As usual, I don't like to make long videos, so we will stop here. And I hope guys you got something valuable from this video. If you did, please share it with your friends and colleagues because your support truly helps us grow. Thank you so much.